So in the last session, we were talking about the manual design process, and also we have seen how to do a sample project design by using some data. So in this particular session, we are going to focus on how to and analyze the isolated square footing. This is what we are going to do in the CSA shape software. So design and analyze the isolated square footing. So here what we have done is, firstly we have completed the manual design. Okay, we have completed the manual design. Now what we are going to do, we are going to do using CSI shape. Okay, using CSI shape software. Right. So this is what we are going to do. So first, let me show you what is the design part that we have done using the manual design process. So if you remember this PDF, so I have already shared this PDF with you. So design of isolated square footing, you can see the problem statement. So a solid footing has to transfer a dead load of 1000 kilonewtons and an imposed or live load of 400 kilonewtons. So from a square column, so you can see the dimensions of the square column, which is 400 by 400 and it is telling that we are going to use Fe415 grade of steel and M20 grade of concrete, right? And the SBC of soil is 200 kilonewtons per square meter, and the maximum settlement in the footing is found to be 25 not more than that, right? So this is what the problem statement. So one thumb rule that we have designed is, when we are designing a footing, we have to check whether it is a square column or rectangular column. So for square column, square footing we have to design, and for rectangular column, rectangular footing we have to design. So here, what is the type of column? You can see the type of column is a square column. So since it's a square column, we are going to design the square footing. This is our blind thumb rule which we were following. And we have already calculated all the dimensions, the total load, the length of the footing, width of the footing, upward soil pressure, and then the depth criteria. All these things we have calculated. Now what we are going to do is, by using the same calculations, okay, whatever the calculations that we have done, using the same data, we are going to model the footing and column in the CSI shape software. Okay, by using this mode data, we are going to model the footing in the CSI shape software. And then we will check whether the factors, whatever the depth of the footing, length of the footing, width of the footing, and also reinforcement, all these things are within the limits or not. Okay, that is what we are going to check down. Right. So before taking you to the CSI Safe software, let me show you the Excel sheet for this one. Okay, I have an Excel sheet which is used to design the isolated square footing. Let me show you that. So in this Excel sheet, you can see this is our Excel sheet. So in this Excel sheet, you have to give some input data. So once you give some input data, what will happen is it will give the output data. Suppose, let's say, what is the SBC of soil in our case? So in our case, the SBC of soil is 200 kilonewtons per square meter. Let me just show you that. Sorry, just give me a second. Right. So here, SPC of soil in our question is 200 kilonewtons per square meter. So I have given the same input value, which is 200 kilonewtons per square meter. And then the width of the column. You can see the width of the column, which is given as 400 So you can check the same thing in the problem statement itself. The length and width of the column is 400 by 400 So you can see the same value, which is 400 is the width of the column and 400 is the depth of the column. So I have given this also. And then the concrete grade. So what is our grade of concrete? M20 is the grade of concrete. So this is also fine. Fe415, the grade of steel is 415. Cover, usually for footings, will take the cover as 50 and the diameter of steel bars. Okay, usually for footings design, we are going to consider 16 diameter bars. So I have given 16. So you have to give these input values. Okay, all the things, whatever that you see in the yellow color, they are all input values. Okay, these are all the input values. Right. So now here one thing that which we have to remember is the axial load. What is the total load coming onto the column? So if you refer to the problem statement, the dead load is 1000 kilonewtons and the live load is 400 kilonewtons. So 1000 plus 400 will be 1400 kilonewtons. So the same value that we have to provide here also in the Excel sheet also. we have to provide the total axial load is 1400 kilonewtons. Right? Right. So this one, let us not talk about this one, which is 8.4. I'll talk about this one in some time. Right. So usually, what is the self weight of the footing we will take? So we will take the self weight of footing as 10% of column load. So just give 10 here. So don't give 10% again. Okay, don't give like this. Just give the number. So 10%. Right. So 10% of the total load, which is 1400. So 10% of total load is 140, which will be the self weight of the footing. And then the total load that is acting equals to 1400 plus 140, which will be 1540. The same values we have here also. You can see, you can check down here. So the total load transferred to the soil is 1400 plus 140, which is 1540 kilonewtons. So from these, we can calculate the area of the footing. So here you don't need to calculate anything. Automatically the Excel sheet will calculate. Okay, the formulas I have given. So these formulas will be calculated. Right. So the area of footing is 7.7 square meter. So how much we have to decide the length and width of the footing? So length of the footing it will calculate, and width of the footing also we can calculate. Okay, the software will calculate. The only thing that you have to change is whatever that is there in the yellow color. Okay, these things you have to change. Right. So now here we have got the size of the footing or length of the footing is 2.77 meters along length and 2.77 meters along width. Okay, but we provide exactly 2.77 meters length and 2.77 meters width? We cannot provide. So we have to round off this value. So I have rounded off this value to 2.8 meters along the length and 2.8 meters along the width. So based on this round of values, it will automatically calculate the area. Okay, it will automatically calculate the area. So that's how it will calculate, right? So this is the data that we have to provide. And then the moment along x-axis, okay, that is moment along length, moment along width, it will automatically calculate. You don't need to change anything. And finally, we will get the depth required. Okay, we will get the depth required. So if you refer the manual calculation also, what is the depth that we have got? You can see here 277.24. But can we provide this same depth? No. Why? Because when you are providing the same depth, the shear criteria will get failure. So if you remember, whenever we are designing the foundations or whenever we are designing the footings, we have two criteria. First one is called as a flexural criteria, and the second one is called a shear criteria. So this 277.24 mm may be safe in flexural criteria, but it may not be safe in shear criteria. What is our rule? Our rule is whenever we are deciding the depth of the foundation, that depth should be safe in flexural criteria and it should also be safe in shear criteria as well. So what we have to do, we are going to increase this depth. So to some round of value. So I'm going to increase this depth, overall depth to 600 mm. Okay, 600 mm is our overall depth, right? So that is what we have to do here. So manually we have to enter how much depth we are going to provide, right? So once you decide the depth of the footing, then automatically the Excel sheet will calculate the actual self weight of footing. Okay, actual self weight of footing, and then weight by percentage of loading. That is self weight of the footing. So here you can see it is given as 8.4 8.4 percentage. But what is the self weight of footing that we usually consider? We usually consider 10% as the self weight of footing. But how much in actual? It is 8.4. So 8.4 and 10, they are almost the same. So there is no problem. Suppose, let's say, when you are getting weight percentage instead of 8.4, if you are getting, let's say, some 3% or 4%, then 3% value is much high, smaller than 10%. So there is a big difference between the considered value and the actual value. So in that cases, what you have to do is whatever the actual one, okay, whatever the actual one that you are going to get here, the same value you have to enter here also. Instead of 10%, you have to enter the same value of 8.4% as well. Okay, so here you can go with 8.4 percentage or 10 percentage. It won't be any problem. But what actually software will do is while designing the manual calculation, we actually consider directly 10% and then we will go with the same calculation. But software will not consider actually 10%. What it does is it will consider the actual value. Okay, whatever the actual self weight of footing, that is 117.60, what this value only it will consider. It will not consider more than this value. That is more than 8.4%, it will not consider. So that's this calculation will not be there in the manual calculation. This will be there in the software calculation. Right. So when you want to change this value, you can change. There won't be any problem. But minimum you have to provide this much. So we have to satisfy that criteria. Suppose if I give 8.4 percentage here, instead of 10 percentage, I am giving 8.4 percentage. And you can see the footing weight has got changed and the total load also got changed. And here you can observe the length and width of the footing. They are exactly 2.75 and 2.75. Again, you can round off this value to 2.8 meters and 2.8 meters. So there won't be any problem. Right. So now the next criteria is, so we have decided the depth required, which is 275, but we are providing 600 depth with the actual self weight as 8.4 percentage. And then the area of reinforcement along length and along width, it will calculate. So you don't need to bother about that. The only thing is you have to select the diameter of bar. So in manual calculation, what is the diameter of bar we have considered? It is 16 So the same 16 diameter bar you have to consider. Just click on this drop down. You can select whichever diameter bar that is required. So up to 30 and a maximum of 10 minimum of 10 diameter we have to provide. Right. So I have decided the diameter of bar and spacing we got, which is 180.07. Here, the spacing value you can provide according to your convenience. But what is our thumb rule? Our thumb rule is whatever the spacing that we are going to get here, you need to reduce this spacing value by plus or minus 25 20 or 25 Okay, this is what we have considered while designing the manual calculation. So suppose, let's say here instead of 180 if you take the spacing as 170 okay, let's say I am taking the spacing as 170 Okay, so I have taken the spacing as 170 but here you can see one condition it is showing down. What is the condition? Fail, revise the depth of footing. Okay, it is telling that it has got failed, revise the depth of the footing. Why it got failed? It is because we have not provided sufficient spacing value. Okay, we have not provided sufficient spacing. So you have to reduce the spacing as much as possible. What will happen when you reduce the spacing? More amount of steel will be required. Suppose let's say I will provide 150 as the spacing. Okay, 150 as the spacing. And let's see whether it is failing in one-way shear or not with respect to the depth criteria. See, here also it is getting failed. Even if you provide 150 also, it is telling that revise the depth of the footing. Suppose, let's say I will revise the spacing value to 100 Let us check that. 100. So when you provide 100 spacing, let us check. Now, can you see? Provided depth is safe for one-way shear. So can you understand now how the spacing influences the failure of one-way shear? Okay, when you provide more and more spacing, then the depth criteria will not be safe. Okay, the shear criteria will get failure. So that is the reason while doing manual calculations also, I told you that we have to reduce the spacing. So here we have got 177, but 150 I have taken while doing manual calculation. While taking 150, we don't know whether it is safe or not. But in actual case, if you check down here, tau v is less than tau c. There won't be any problem. But you can still see the failure is happening. Why? Because it is failing in two-way shear check. Okay, it might be failing in two-way shear check. So that's the reason when you are designing the footings, make sure the spacing of the footings, if you reduce as much as possible, but don't reduce too little value. Reduce some better values so that you will understand whether the spacing is required with respect to the shear criteria or not. So here I am considering the spacing as 100 and therefore the one-way shear check is safe. The whatever the provided depth that is there, that is safe. And these things you don't need to calculate. Everything will be calculated by the Excel sheet itself. And you can see the tau v less than tau c value. So you can see provided depth is safe in shear also, two-way shear as well, that is punching shear. And then the final design details. So width of the footing, length of the footing, overall depth of the footing, you can see here. And along width, the reinforcement is 16 diameter bars with 100 spacing. Along length, the 16 diameter bars with 100 spacing. And then you can see the remaining details here. So this is all the other types of footing, stepped footing. We'll see these ones in the later case. So this is all about Excel sheet calculation. Now what we will do is we are going to use the software calculations. Okay, we will use the software calculations in order to work with this one, right? So let us go with the software calculations, right? So here, as of now, if anybody is having any doubt, you can unmute and ask the doubts. Right. So I can consider you don't have any doubts. Right. So now, first we have to start the model. So how to open a new model? Just go to File, okay, and then New Model. Okay, dialog box appears. So you can see the dialog box. What is the design code? Design code is IS456-2000. And then design preferences and project information. We can change this also later. No problem with these ones. But units is very important. So units, which units we need to go with? We need to go with metric systems or metric default. Just click on metric defaults and then click OK. So units we have set. So do we need to go for blank or do we need to go for grids only? Anything we can go. There is no problem. So currently, what I'll do is I'll go with blank. Okay, I don't want any kind of grids. I will model the grids according to my convention. Actually, we don't need any kind of grids here. I'll tell you the reason. So just go with blank and then click OK. Right. So you can see there is no grids. These are actually the grids, external grids. Okay, the grids which we have to model. So we know grids means it will be like this. So grids along y-axis and grids along x-axis. So these grids we don't want. Right. Now let's say you don't want to see the background grids also. You are seeing some grids, right? I don't want to see these grids. So how to disable those grids? In order to disable those grids, just click on this one. Okay, set default option. You can see here. Okay, set display option, not default, set display options. So just click on this one. Okay, you can see at the top. So if anybody is getting confused where my cursor is, so you can see here, set display options. So click on this one and then you can see this option called horizon. Okay, there is this option called horizon. Just uncheck this one. Okay, uncheck this and then click OK. Right, you don't see any kind of grids. It's a plain one. Right. So that's how you have to set up the project model. So now what is the first step that we have to design? The first step is we have to define the material properties. Okay, we have to define the material properties. So I'll write the steps. So the first step is material properties. This is what we have to define. Okay, material properties. So how to define the material properties? So material properties and you can say section properties also. Both we will make it. Section properties. Right. So how to define the material properties? So in order to define the material properties, we have this option called define. Go to materials and then a dialog box pops out. And here we have to define the materials. What are our materials? Our materials are M20 grade of concrete. So this is first one. And the second material is grade of steel, which is Fe415 grade of steel. So these two materials we have to define. Right. So how to define? So you can see add new material, click on that and then give the material name. Suppose let's say I'll give the material name as M20. Okay. And then material type. So the material type is concrete. Right. And then the weight of steel, I mean, weight per unit volume, which is 25. So that's what unit weight of RCC, 25 kilonewtons per cubic meter. And then this one, modulus of elasticity. So how to get the modulus of elasticity? 5000 root FCK. That's the formula. Okay, 5000 into square root of FCK. What is FCK? 20. That is grade of concrete. So 5000 into square root of 20. Just click enter. You will get the value automatically. And the Poisson's ratio we can take directly as 0.2. And then coefficient of thermal expansion, let it be the same value. Shear modulus also let it be the same value. And then the concrete cube compressive strength, which will be 20. Okay, concrete cube, we are designing M20 grade of concrete. So M20 we have to give. So with this data, just click on OK. Okay, just click on OK. Right. You can see M20 grade of concrete has come. Now we have to define the second material, which is Fe415. So just click on add new material and the material name is Fe415. Okay. and then the material type is rebar, sorry, not tendon, rebar, and then weight per unit volume. What is the unit weight of steel? 78.5 kilonewtons per cubic meter, right? And then Young's modulus of steel, 2 into 10 power 5, 2 times of 1, 2, 3, 4, 5, right? So is it 5? 1, 2, 3, 4, 5, right? So 2 into 10 power 5, and then minimum yield stress, that is grade of steel, Fe415, minimum tensile stress, that is also grade of steel, which is 415, right? So, and then click OK, right? So we have given the grade of steel also, okay, that is Fe415. So we have defined the two materials, right? Now just click OK, right? So now the next thing is, this is what we have designed. We have given the material properties. So now let us give the section properties. What does it mean by section? That is slab properties or foundation slab properties. So let us give the section properties. So how to give the section properties? Go to define and then go to this option called slab properties. So just click on slab property and then we have to add a new property. So just click on add new property and then we have to give the property name, which will be FT. So what is the overall depth of the footing? So we have taken it as, let me check. So overall depth of the footing, we have taken it as 600 mm. You can see here. Okay, 600 mm. So 600 mm as the overall depth of the footing. So let us go with 600 mm only. Right. So FT underscore 600 or FT hyphen 600 hyphen M20. You can give any name. That's completely up to you. So I usually follow this method. And then the slab material. What is the material of the slab? Concrete. It's basically M20 grade of concrete. So, and then the type. So what type it is? So it is actually a footing. So just give footing here. Remember, we can also give slab as well. There is no problem. So usually we'll go with footing only. And what is the thickness? Thickness is 600 mm. The thickness in the sense, the overall depth, 600 mm. Right. And then click OK. And then click OK. Right. So what is the first material that we have defined? We have defined the slab property. What is the second material? We have to define column. So first we have defined the foundation slab, and inside the foundation slab, we will have the column. So now the second one we have to define, that is column property. So how to define the column property? Just go to define. Okay, go to define and you can see the column properties. So click on column properties and we have to add a new property. Just click on that and then give the dimension of the column. So CM. So I think dimension of the column is a square column, which is 400 by 400 mm. 8. So 400 by 400 mm. So let us go with CM 400 by 400 underscore M20, right? So I'm giving the property name as this one. And then the material. What is the material? Material is M20. Okay, the column property is M20. And then column shape, you can give rectangle shape. It will automatically take the dimension whatever we give, right? So parallel to two axes. What does it mean? That dimension, that is 400 mm along say, two axes and 400 mm along three axes. So you can refer this diagram also in the dialog box. Can you see this diagram? This diagram also you can refer while giving the notations. If you confuse which is two axis and which is three axis, right? Right. So now the next thing is parallel to two axis and three axis, 400 mm, and remaining data we don't need to bother. Just click on OK. Right. So we have given the column property. So we have only one column type. So I'm giving only one column type. If you have more types of columns, you can just click on add new property and then you can add the remaining ones. Right. So just click OK. Right. Now the next thing is, so first we have given the slab property. Next we have given the column property. And then where this slab and column will rest on, they will be resting on soil. So the next property is soil subgrade property. Okay, the next property is soil subgrade property. So here we have to define the soil subgrade property. If you remember in the last session, I was telling subgrade modulus K equals to SBC of soil. We have defined this formula, SBC of soil divided by allowable settlement. SBC of soil divided by allowable settlement. What is SBC of soil? In this case, it is 200 kilonewtons per square meter, and the settlement is 25 mm. So I'll convert into meters. It will be 0.025 0.025. So whatever K value that you are going to get, that is your soil property. Okay, that is your soil property, right? So let us define that. So how to define the soil subgrade property? Go to define, and then you can see this option called soil subgrade properties. So click on soil subgrade properties, and here we have to give the property. So either you can modify this one or you can create a new property also, no problem. So just click on add new property, okay, and then give the name of the property. So what is the name? I'll give it as SBC. The value of SBC of soil is 200 at the rate. What is the settlement? 25 mm. So I'll give in this way. You can give anything, right? And then, so subgrade modulus compression only. That is what we have discussed in the last session. So subgrade modulus. So how to calculate this value? So this value is K. Okay, subgrade modulus is defined with K. So what is the formula for K? The total SBC, that is 200 divided by settlement. What is the allowable settlement? 25 mm. So 0.025. Just click enter. And you can see the subgrade modulus value is 8,000 kilonewtons per cubic meter. And then we have discussed about this one also in the last session, why I am taking only compression only. So just check compression only and then click OK. Click OK. You can see SBC got added. If you want to delete this one, soil one, you can select this one and then click on delete property and then click OK. Right. So we have given the, with this, we have completed the modeling of material properties, defining of material properties and defining the section properties. Now, the next thing is we have to do the modeling part. Okay, modeling. So what are the things that we have to model? So we have to model footings. That's the first one. And then we have to model the columns as well. Both we have to do. So we have to do the footing modeling and we have to model the columns modeling. So first let us do the modeling of footing. Okay, let us do the modeling of footing. Then we will do the modeling of column. So how to model the footing? So in order to model the footing, we have this option which is called as quick draw areas around a point. This one. Okay, quick draw areas around a point. This one. So let me keep the cursor there. So if I keep the cursor, you can see quick draw areas around points. So just click on that, and here you can see a dialog box coming down. So the type of object is a slab and shape of object is rectangular slab. Select the property. So currently we have only one type we have defined, FT600 underscore M20. So select this, and what is the dimension of the footing? Okay, what is the dimension of the footing? So how to get these dimensions of the footing? We have got the Excel sheet. In Excel sheet, what is the dimension we have considered? Provide length of the footing as 2.8 meters, width of the footing as 2.8 meters. So select those things and give those values. Okay, so here also we have to give X dimension is 2.8 meters and Y dimension is 2.8 meters. And the trim mud slab edges, let it be S. Okay, now once you specify these dimension, what will happen? You are going to draw an area around a point. So what does it mean? So now anywhere in the window, you just click there. Okay, let us click anywhere in the window. What does this point represent? This point represents you are going to draw an area around a point. That means if you click on any particular point or anywhere in the screen, around this, a rectangular slab or a square slab with a dimension of 2.8 by 2.8 meters will be modeled. That means if I click somewhere here, anywhere you can click. So automatically a square slab will pop out. Okay, something like this will come. Let us check that. So just click anywhere on the screen. Right, can you see? So a slab has got popped out. So that's how you're going to draw the slab. So how I have drawn the slab? I have drawn the slab based on quick draw areas around points. Okay, quick draw areas around points. So you will see a squared slab which has got model. Right. So now let us draw the point. Why we need to draw the point? The reason is now we have to model the column. So currently we have modeled the foundation slab. Now what is the next thing? We have to model the column. So where column will come? Somewhere in the center. But how to define the center point? We don't know. Right? We cannot define randomly by clicking, by assuming that this could be the center, something like that. So we have to be careful while deciding the central point. So in order to decide the central point, we have to draw a point. Okay, we have to draw a point. So how to draw a point? So in order to draw the point, just click on this select object so that the command will be disabled. Right. So just go to draw, and then you can see an option called draw points. Can you see this one? Where is that? Yeah, draw points. So just click on draw points, and here you can select the type of object as point. Okay. And then plan offset, let it be 0. Plan offset along X and Y, let it be 0. Now what you have to do, move the cursor. Okay. Just move the cursor to the central point of your slab, whichever that has got model, just move the cursor there. Now, if you keep on moving, okay, what will happen is at some point you will see a triangular shape. Can you see a triangle shape in red color? That is actually the midpoint. Okay, that is actually the midpoint. Once you see that triangle shape, just click there. Okay, just click there. So that's how you can define the point. Okay, that is how you can define the point. So this is how we here, based on this particular point, we are going to model the square column. So square column will be modeled around this particular point. Okay, around this particular point, we are going to model the square column. This is one way of modeling. Okay, this is one way of modeling. Let me show you the second way also. So now in the first way, what I have done, first I have modeled the footing. Okay, first I have modeled the footing, and then I have defined the center point. That is what I have done. Now what we are going to do is I will define the center point first, and around the center point I will model the footing. Okay, let me show you that. Right, so let me just show you that. So for that I will model somewhere here. Right, so let me give something like this. Right, so let me give here. Right. So here I'm going to model. So what is the second, how to model, how to do the same thing in the second way? So for this, we can see an option, something like, let me show you that. Just let me check that point. Right. So just go to draw. Let me show you one more option, which is like, I want to show you the snap options. Let me click on right click, and then there is this option called the snap options. Just click on snap options, and then make sure to select points and then line ends and midpoints, so that you will understand which is line end and which is a midpoint. And then grid intersections, let it be like this also. Let these things be checked. And then perpendicular projections, you will see a perpendicular line. And then intelligent snaps, let it be this one. And then click OK. Right. So this is just to see the points, some points, so the like midpoints, all these things. So how to go with this one? Just right click and then snap options. So whichever ones you are going to check, you are going to see all those ones. Right. So now let us model the point. So first I am going to model the center point. Somewhere here I am going to model the center point like this. I will model the center point here. So how to model the center point? So just go to draw and then go to draw points. Okay, draw points, and then the type of object is point. Plan offset X is 0, plan offset Y is also 0. Let me click on somewhere in the screen. Let me click here, and you will see the plus symbol. So first what I have done, I have modeled the point. Okay, first I have modeled the point. Now what I'll do is around this point, okay, around this point I am going to model. Okay, around this point I am going to model the footing. Like this I'm going to model footing slab or foundation slab I'm going to model. Right. So first what I have done, I have modeled the point. Now the next thing is we are going to model the area around the point. So how to model the area around the point? Let me disable the command. So in order to model the area around point, you can see here, click quick draw areas around point. So select this one and then give the properties. So type of object as slab and then rectangular slab. Okay. And then the property, which is FT620, X dimension is 2.8, Y dimension is 2.8, trim slab at edges, yes. Now you click on this point. Okay, just click on the center point. So click on that and you can see. So these are the two ways of modeling the slab elements. Either you can model in the first way or in the second way. What we have done in the first way? In the first way, first I have modeled the rectangle slab, then I have defined the center point. In the second way, what I have done? First I have modeled the point, and once after modeling the point, around this point, okay, around this point I have modeled the slab. Either ways it will work, no problem with any way. right? Let the both things be there, or you can delete any one. So I'll select everything and then I'll delete this one. It's not required. So let me go with this one only, or any one you can go with. Right. So now we have modeled the foundation slab. What is the next thing? The next thing is we have to model the columns. Okay, the next thing is we have to model the columns. So how to model the columns? So in order to model the columns, okay, we have this option which is called as draw columns. In the left pane, you can see this one, draw columns. Okay, this I shape you are seeing, right? That is actually draw columns. Let me keep the cursor there and you will see the point. Can you see? Draw columns. Right. So let us draw the columns. So before drawing the columns, let us assume it in this way, the depth of the footing. Okay, the depth of the footing as 3 meters. Okay, let us keep the depth of the footing as 3 meters, not the overall depth, depth below the soil. Okay, so I'll give it as 3 meters. So what does this 3 meters represents? Height of column up to ground level. Okay, that means if you consider this as your ground level, okay, so the height of the column up to ground level is 3 meters. That is what I'm going to consider. Okay, from the bottom. Okay, right. So this value is important. So depth of the footing is taken as 3 meters. So this is not there in the question, so you can keep that value. So let us keep the footing depth as 3 meters. Right. So based on this, we are going to draw the columns. Right. So just click on draw columns, this option. You can see in the left pane, click on that. And now here we have to define the properties of the column. So select type of object is column and then property above, property below. Do you want the column to be modeled above the footing or below the footing? Suppose if this is your footing slab or foundation slab, do we need column above the foundation slab or below the foundation slab? We don't need the column below the foundation slab. So we need the column above the foundation slab. So here what you have to do is property below. You have to keep it as none because we don't need the column at the bottom. And the next thing is property above. So we need the column above the footing only. So select the footing column type. So I'm selecting the property above, that is column type as CM 400 400 M20. And then height below. Do we need any height below the footing slab? No. So 0. What is the height of the column above the footing slab? We have considered it as 3 meters. So just give it as 3 meters. So height above is 3 meters. And once you give the height above as 3 meters, plan offset. Do we need any offsets? No. And then angle also we don't need. And then cardinal point. This also we have discussed in the previous session. So let it be 0. Let it be 10. So now just click on the center point. So make sure to zoom. And then once you see the red color square symbol, you can see once I move the cursor to this plus symbol, you will see red color square. Only after seeing that, click on that. That means if you're going to make the column or place the column exactly center. So just click on that. And you can see a square column has been modeled. And you can see the command is still active. How to disable the command? Just right click. Okay, right click. Or you can also click on select object. Okay, just click on select object. Right. So the command has got disabled. Now we know that the square column has been modeled. In 2D shape, you are basically in 2D view, that is in XY plane. If you go to 3D, just click on 3D. Right. Can you see the column here? The vertical one. Can you see the vertical one? That is basically the column. Okay. And this one, the rectangle, the square one you can see here, that is actually the foundation slab. So this one is actually the foundation slab and this is actually the column. Now, as I told you in the last session itself, for every column, we have 2 points, one point at the top and one point at the bottom. But when you are loading, when you are deciding the loading, you have to apply the loading either at the top or at the bottom. So usually what we follow, we apply the load at the top of the column, top point of the column, right? But this is one thing. This is with respect to loading. But there is one more thing that applies by default, which is whenever you design any element, let it be the column or beam, whatever the line element that you are going to design. So these are called as line elements. Okay. Whenever you are designing the line elements, what will happen in the CSI Safe software or in ETAP software is by default, okay, by default, the ends of the column, okay, by default, the ends of the columns will be modeled. Okay, the ends of the columns will be modeled as a hinge models. Okay, hinge supports. So by default, the ends of the column will be modeled as hinges. Okay, by default, the ends of the column will be modeled as hinges. So we don't need hinge support at both ends. Okay, you don't need the hinge support at both ends. So what we have to do is on column top and bottom, hinge support will be assigned by default. That you remember. Okay, on column top and bottom, hinge support will be assigned by default. But we don't need hinge support at the top. Okay, we don't need any kind of hinge support at the top. So what we have to do is we have to remove this hinge support. Okay, we have to remove this hinge support. So how to remove the hinge support? Okay, we don't need hinge support at the top, so we need to remove this one. So how to remove this one? So in order to remove this one, just drag it from left to right. Okay, hold your cursor. Okay, hold your left click in your mouse and then drag it from left to right, and then make sure this point, whatever the top point, this one, let me show you that this particular point should cover. Okay, so let me drag it from left to right and make sure of it. And then you can see at the bottom, 1 point selected. Okay, you can see at the bottom, 1 point selected. Now we don't need this support. Okay, we don't need this support. What is that support? Hinge support. So now select that point and then we have to remove the support. Okay, we have to remove the support. So don't click on directly delete. It will also work, but there is another way. I'll show you the important way. So select the point, whichever you want to remove, and then go to assign. Okay, go to assign, and then you can see this option called support data. Okay, support data. And then there is this option called point restraints. Okay, point restraints. So click on point restraints, and you can see the types of supports here. This one is basically the fixed support. This is hinge support. This is roller support, and this is no support. The dot indicates no support. So now we don't want to give any kind of support. So just select this one. Okay, select this one and then click OK. Now can you see? If you drag it from left to right, okay, there won't be any kind of support, right? So now if you go to the XY plane, okay, just go to the XY plane. Now we have to model the other part. Right. So this is how you can remove the support. Right. Now the support has been removed at the top of the column, not at bottom, top. Right. So the next step is we have to give the soil properties. Okay. The next step is soil subgrade properties, the value of K. Okay, the soil subgrade property. So how to define this soil subgrade property? So in order to define this soil subgrade property, just click on the slab. Okay, the bigger one, the bigger slab, whatever that you see here, just click on this bigger slab. Right. So let me click on this one. Once you click this one, can you see at the bottom left side, one area, 4 edges have been selected. So this is edge 1, edge 2, edge 3, and edge 4. So 4 edges, and this is completely one area. So one area, 4 edges selected. Right. So now we have selected the footing or the foundation slab, you can say. Now what we have to assign? We have to assign the soil subgrade property for the footing. Why I have selected only the footing? Because when you are in the real-time conditions, whenever you apply the soil subgrade property or SBC of soil, the soil mass will be in touch with the foundation slab, not with the column. So that's why I have selected the foundation slab, not the column. I have not selected this one. I have selected the foundation slab. Right. So now let us assign the soil subgrade property. So how to assign that? For that, there is this option called assign. So just click on assign, and then we have to assign the support data. So click on support data and then soil properties. So click on soil properties and then select this one. Okay, we have already defined this. So select this one and then click OK. Once you click OK, what will happen is this value, that is a 200 kilonewtons per square meter is SBC of soil, will be applied throughout the footing, okay, or throughout the foundation slab. You will see plus symbols here. Let me click OK. You will see that. Click OK. Can you see the plus symbols here? When you see plus symbols, that means the SBC of soil has been applied. And you can see at the center also SBC 200 at the rate 25. That means we have successfully applied or assigned the soil subgrade property. Okay, we have successfully assigned the soil subgrade property. Now let's say how to change or how to remove the soil subgrade property. I don't want this one. I want to remove this one. How to remove? So in order to remove the soil subgrade property, technically you cannot use this undo option. Okay, you can see this undo option, right? We cannot use this undo option to remove the SBC of soil. Right. So what we have to do? So in order to remove the SBC of soil, we have to go to assign again. Okay, go to assign, go to support data. Right. First, let us select the footing, the foundation slab. Go to assign and then support data soil properties. Okay, make sure to select the foundation slab. Without selecting, it will not work. So how to check whether it got selected or not? You have to always keep your eye at the bottom left side of your screen. Currently, it is not selected. Once I click on the slab, you can see one area, 4 edges selected. Right, go to assign, support data, soil properties, and here we have to select this one. Okay, that's what we know. So now if you select none, what will happen? So nothing will be selected. So let me select none, click OK. Now can you see? Nothing is there. That means SBC of soil is not applied. So that is one way of selecting and applying or assigning the soil subgrade property and de-assigning the soil subgrade property. There is one more way also. So what is that way? So the other way is just keep the cursor on the slab. Okay, just keep the cursor on the slab and then right click. Okay, and then right click. So what you have to do, just keep the cursor anywhere on the slab, the foundation slab, not on the column, foundation slab. Click on, right click. Once you right click, you can see this option, and in the background you can see this one, the yellow color line is getting blinked. What does it means is, it means this option, I mean this particular foundation slab has been selected. Okay, whichever portion that is blinking, that indicates that section has been selected. Let me show you one more time. Suppose if I keep the cursor on the column and then right click, okay, it will be working. So anywhere it will work, right? So but make sure you're going to select here and then keep the right click. So once you click, once you do right click, a dialog box pops out, and here we can define the soil property. Can you see here? Slab property. So once you give the slab property, you can see footing that is done, and here at the bottom you can see soil property. So here it is none. So now we want to give the SBC of soil. Just click on this none. Okay, you can see this one. Select this and then select SBC 200 at the rate 25 mm. Click OK and then again click OK. Right. Can you see? The SBC of soil has been applied. So that's how we can apply the SBC of soil. So once the soil property also done, the next thing is assigning the loads. Okay, let us assign the loads. What is the total load that we have? The total load is 1400 kilonewtons. This is the total load, 1400 kilonewtons. So let us apply this 1400 kilonewtons of load. Right. So how to assign the loads? The total intensity of load is 1400. If you have a confusion, you can check here also. You can see dead load plus live load is 1400. Right. So let us assign this one. So just click on 3D view. Okay. You can see the SBC of soil has been applied. Column, you can also see everything. Right. So now where we are going to assign the load, we are going to assign the load at the top point of the column. Okay, we are going to assign the load at the top point of the column. So how to apply the load on the top point of the column? Just click on that point or drag it from left to right so that this point has to be covered. Right. You can see at the bottom, one point selected. Right. This is the point. So here we are going to apply that load, 1400 kilonewtons of load we have to apply here. Right. So how to do that? So for that, go to assign. Okay, click on assign and then load data. So which type of load? It's a point load. So click on point load and then we have to select, is it a dead load or live load? It's a live load. So select live load. And what is the intensity of live load? 1400. That's the intensity. Moment and all we don't need to bother. Let it be like this. And then size of load for punching shear. What does it mean? It means the dimensions of the column. What is the dimension of the column? 400 by 400 mm. You can see here 400 by 400 mm. So let me give 400 here and 400 here also. And here check replace existing loads. If there are any existing loads, it will replace them. Right. Select replace existing loads and then click OK. Once you click OK, Can you see the load that got applied? 1400 kilonewtons of load. So that's how the load will be applied. So you can see the load, which is in the red color, acting downwards, that is 1400 kilonewtons. So here we have assigned only one load. So basically, what is the load that we have assigned? We have assigned the live load, that is 1400 kilonewtons. But in real-time scenarios, we have load combinations. Okay, we have load combinations. What does it mean by load combination? We have dead load plus live load, dead load plus live load plus wind load. All these things will be there. So in real-time scenarios, we have the load combinations. So since this is a sample analysis, let's make a simple load combination. So how to make the load combination? So in order to make the load combination, so first we have to define them. So just go to define, and then you can see the load combinations. Can you see here? Load combinations. Click on that. And here we have to add the load combinations. So click on add new combo, and here the combination name. So let's say first I will give service load combination. That is dead load plus live load, right? So the type of combination type is linear add, and then auto combination, let it be no. And here we have to add the loads. Okay, here we have to add the type of loads whichever we have. So first select dead load. So click on this drop down and select dead load, and then click on this drop down and then select live load. And here it is scale factor. So when you are giving the service load combination, the scale factor has to be 1. Okay, for factored load, it is 1.5. For service load combination, it is just 1, right? So dead load, live load we have given, and it is basically the service load combination. So since it's a service load combination, we have to check this option, service normal. Okay, it's a normal load, which is in the service condition. Okay, not in the factored condition, in the service condition. So let us check this box, service load combination, and then click OK. Right, you can see dead load plus live load combination. This is service load combination. We have to apply the factored load combination as well. So how to apply? So again, we have to add a new combo and then give the combo name, that is 1.5 dead load plus 1.5 live load. Okay, that is combination name. Let linear add and then auto combination no, dead load plus live load. Okay, so here the name what we have to select, the load name what we have to select is, the load name. Yeah, so the load name what we have to select is, just click on this drop down. You can see dead load plus live load. So we have to select dead load plus live load combination. Okay, dead load plus live load combination, or you can also define in this way. So select dead load first, okay, and then select live load first, live load next. And then what is the scale factor? What is the factor of safety for loads? It is 1.5. So just type 1.5 here and 1.5 here, right? So that's how we can define the factored load combination. But here, if you observe at the bottom, we have service load combination, but not for factored load. But instead of factored, we have this option which is called as ultimate load combination. Okay, we have this option called ultimate load combination. So here we have to check this one. For service load combination, we have to check service normal. For factored load combination, we have to check strength ultimate. That's a maximum. It means maximum. Right. Check this one and then click OK. Right. So we have defined the service load combination and factored load combination. So this is how we can define the load combination and then click OK. So once we give the load combination, the next step is we have to do the analysis part. Okay, the fifth step is analysis. This analysis we will discuss in the next session, because once we do the analysis, I have to tell you like the continuation part, there are many things that will come out. So I will talk about this analysis part in the next session. Okay, so if you are modeling this one, so what you have to do is make sure before closing this one, make sure to save this one. So let me click on save to file and then save, Control S, or just directly save. So here what I'll give is isolated square footing. Right. Once you save, make sure of saving this one. So once it is done, then you can close. Right. So that's from my end for this particular session. If you have any doubts, you can unmute and ask your doubts. Thank you.